from some of the research I've looked at, for example, charging an electric vehicle in a country like Australia, which has a low renewable energy grid and a large coal dependence. Over the life cycle of a vehicle, charging an electric vehicle is unlikely to be better over the life cycle on emissions than a conventional vehicle at this point.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by fellow Kiwi Brad Eyes. Brad's actually had a really interesting journey, starting out with a mechanical engineering degree before heading to the US, pursuing his dream of working in a high-end race team. He managed to land exactly that dream, working in a IndyCar team, building up through the ranks and basically being involved in systems engineering through to performance engineering, and as well as that, he got involved in race strategy. He got the opportunity to move back to Australasia, working in Australia in the V8 Supercars series for DJR Team Penske, at the time going through one of their most successful periods ever. Learning a lot from that, he was involved in just about every aspect of running that Supercars team at the racetrack. In a strange and somewhat unusual twist though, Bradley's kind of gone full circle and is now involved heavily in sustainability, specifically looking at electric vehicles as well as a larger picture for a net zero outcome in our future. And this is somewhat of a different path to most of our podcast episodes. However, if you have been taking notice of what's going on over the last decade or so, it's no surprise that we really need to sit up and take notice. And most of us as motorsport enthusiasts, sustainability and being green is probably not at the very top of our list and maybe not even on our radar. So this discussion, while in some ways could be a little bit of doom and gloom, there are some rays of sunshine at the end of it. So be prepared to learn a little bit about what we might have in store over the coming decades. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Brad. Thanks for joining us today. And as always, let's start by learning a little bit more about your background and specifically how you got interested in cars and motorsport.
Yeah, thanks for having me, Andre. Really appreciate it. Yeah, I guess I sort of always grew up with a bit of an interest in cars when I was younger, but sort of wasn't really involved too much until I think I went to university and I studied mechanical engineering. And then during my time there was a program that started up for a university competition where you would design and build a race car and you'd go and compete against other universities around the world. And so I was really fortunate to get into that program from the beginning. And from that point on, I sort of just fell in love with the technical side of racing and sort of that performance-driven analysis. And we were quite lucky through that program. You know, we were building carbon fiber chassis, and we had a Yamaha R6 engine, which eventually ended up supercharged, and pretty serious aero program, building wings and whatnot on it as well. So it was a really cool opportunity at a young age to get to play with some really technical design.
Yeah, you're making me jealous. So I assume here you're talking about Formula SAE?
Yeah, that's the one. Yep.
Okay. Yeah, so you've gone down a path that has been a pretty common blueprint for a lot of our guests. Unfortunately, the university I went to didn't have a Formula SAE program, and I was always really jealous of those that got involved. Can you give us a bit of an understanding of what your role was within that team, what you're actually working on with the Formula SAE project?
Yeah, I sort of had a variety of roles, sort of worked with the engine team for a little bit. As I say, we had a Yamaha R6 engine, which we eventually were running a supercharger on, so doing a lot of the dyno testing and building of that. I ended up doing my fourth year project where I think I designed and did a bunch of analysis on the dry sump system that we had on it. We actually had the motor flipped over on its back, so we had to have a dry sump for it. So yeah, did a couple of years in the engine program. I was a driver for several years throughout it, and then I also took on a bit of a role as a race engineer position through that time as well, just sort of trying to run the testing program and the drivers and sort of try and enhance it in sort of a more professional way. So yeah, a few different roles there.
So yeah, it sounds like you wore a few different caps. Now, the fact that you said you're involved with the actual driving, I've always been interested. These things look like they weigh about 2 kgs, and obviously with a supercharged Yamaha R6 engine, it's probably not lacking in the horsepower department. What are they like to drive?
Yeah, they're incredibly fun. I mean, horsepower-wise, at least back then, you had to have I think it was a 20 mil air restrictor on it. So they were quite limited by the power they could make, but generally, the cars were, I think a light car might have been about 150 kgs, and the heavier ones were in sort of the low to mid 200s. So they're still quite light. So, sort of accelerating to 100 k's, they were very fast. So a lot of fun, and you generally had a pretty good slick tyre on them as well. So yeah, heaps of fun to drive.
Okay. So at the point you finished your mechanical engineering degree, you've obviously got a bit of a taste of a variety of different roles within motorsport. What's next for you? How did your sort of trajectory go from there?
Yeah, so I was lucky towards the end of my university program. I worked in a series in New Zealand called Formula Toyotas, and I was lucky enough to work with a guy who was running a team there who was a chief mechanic at McLaren for a long time. So I sort of worked as a mechanic and engineer under him, and that really gave me sort of some really good skills in just how a top professional team runs in motorsport. And I sort of always wanted to, at that point, go overseas and see if I could work in top levels overseas. And I decided the US was where I wanted to go. So I got myself over there and was really lucky to go into IndyCar and got to work as an engineer in IndyCar for several years, which was a bit of a dream come true, I guess.
Okay, let's just talk about how that all came to be, because that sounds like you've just really compressed something that's quite complex into a couple of throwaway sentences. One of the issues I think with New Zealand, I love the country, but our motorsport industry here is all but non-existent. There's not a lot of big teams. There's not a lot of sort of corporate money being poured into motorsport. So by definition, as I see it, that kind of limits the upper echelons of our local motorsport scene. So rightly so, if you want to really make a career for yourself, I think at a minimum Australia, but otherwise the US and the UK are really your options. But breaking into those markets, particularly IndyCar or Formula One, I'm guessing it's not that simple. How did you actually go about getting that position?
Yeah, look, it was, when I look back at it, it's pretty incredible. Yeah, for me, I just said I was going to go do it, and I booked the plane ticket and just basically was cold calling and emailing any contact I could find. And then, was really lucky to get picked up with one of the smaller teams just before I went over there, and sort of went under their wing as an engineering intern. And it was, just incredibly lucky, I think. But I think it just sort of came back to just being a young Kiwi, just driven, and having that determination to just put in their work ethic and do whatever it took to go. And yeah, I'm just really lucky that it it worked out for me, and it ended up being an incredible experience.
Yeah, well, I mean, clearly it has worked. So let's dive a little bit further into it. At an entry into an IndyCar team as an engineering intern, what's that involved? What are you actually doing?
Yeah, well, there's a lot of electronics on those cars. So really, as a entry engineer, you're what you'd call a data engineer. So you're running all the electrical systems on the car, the data analysis, the sensors, making sure that they're all calibrated and working, making sure that the telemetry data that's being sent back to pit lane is working, all of the radio communications. So that's sort of your primary responsibility, and those things are a lot of work to make sure that it's all working correctly.
So I'd almost refer to that as maybe more systems engineering. Would that be a fair way of describing it?
Yeah, I think in sort of an industrial sense, that's what it is. But I guess, yeah, you're sort of covering a lot of different tasks there, which is a lot of responsibility that you've got to make sure works. So, and when it doesn't work, it's very apparent. So, yeah.
So make sure it works.
yeah.
I don't really follow IndyCar, so I'm definitely not an expert on the series. But from what I understand, you have your spec engine supplier, and as a team, you're not actually involved with anything to do with the engine. Is that correct? They've actually got their own engineers from Honda, for example, that are looking at data from the engine and making sure that's doing everything it should do and adjusting the calibration as required.
Yeah, so IndyCar's what you call a one-make series. So you purchase the car from the designated manufacturer, which IndyCar has been Dallara for a long time, and they really design the chassis and the bulk of the car. You'd normally lease your engine from a manufacturer, and that would come with a program to run the engine. And then, when I first started there, Honda was the only manufacturer. So the car was all pretty much the same. And then Chevy came back into it during the time that I was there. And that's when they went to having different aero kits that were designed by the manufacturers. So that was a choice that you had as well. And yeah, so you're really kind of somewhat limited to the parts that you're allowed to change, but there is definitely a big enough scope on certain components that you can control yourself, and leaves enough room for engineers to do their thing and form a difference between the cars.
Yeah, okay, perfect. That was going to be my next question. Obviously, in a spec series that's tightly controlled, how does one team end up with a car that's significantly faster than another team? So can we talk about some of the parts where you do have flexibility? You mentioned the different aero kits which you can choose, but what is the extent to the things that the team have control over where you can actually get a performance advantage?
Yeah, I think, in terms of actual components, dampers are the big one. But then the design of the car, has a lot of window for moving the suspension components around, so the actual kinematics and dynamics of the suspension, you can change quite a lot, and there's a lot of differences. There's different differential settings you can be running. There's different gear ratios you can be running. The aerodynamics, generally the series will sort of spec windows that the aerodynamics can be in for different tracks, whether it's ovals or road courses or street circuits. So you'll sort of have a window of aerodynamics that you can sort of change, whether it be wing angles or components that you can add or subtract from the car. So, when you combine it all together, there's
quite a range of sort of the working window for a particular chassis.
Exactly. Even though it's a spec car, there's a lot of room for differences you can get. And when you're chasing, small percentages of differences, it can make a massive impact. So
yeah, no doubt. You just mentioned sort of the road courses versus the ovals, and on face value, I'd be thinking to myself that just about every element of a setup's going to be completely different between the two. Is that accurate?
Oh, yeah, absolutely, yeah. And I hadn't watched an oval race before I went over there, which was fascinating. So, I wasn't too sure what to think about the oval racing, but I was actually really fascinating once I got into it, particularly if you're a technical minded person, just the ability where you can you're narrowing and chasing on like such small percentages. You've really only got 4 corners or 2 corners, depending on how you look at the circuit. compared to a road course or a street circuit that may have 10 to 15. So it gets quite fascinating, the detail level you're going down to in the vehicle setup, and even the race strategies when you're working inside the races, just the technical aspect of how you're trying to win the race or finish the race. From the outside, it might be harder to see, I guess, on TV, but for a technical person, once you're in there trying to figure it out, it's actually really fascinating, at least I found.
Yeah, right. Okay. I'm interested with the driver's sort of ability to affect the balance of a car over a stint as fuel burns off, as the tyres degrade, etc. Do the drivers actually have any essentially levers that they can pull from within the cockpit to adjust the balance, or is that only going to be able to be done in a pit stop?
No, at least back when I was involved, and this is going back several years now, they did have control of a front and rear roll bar from inside the car. So yeah, they were able to adjust that. And then if you watch the races, you'll also hear them talk about the weight jacker, which is a small hydraulic cylinder that sits on top of the spring on one of the dampers. And so that just allows you to add a little bit of cross weight or take some cross weight away from the car, which has a big impact as well. So yeah, there's a few small tools that the drivers can use, but they have massive impacts on the balance of the car for sure.
Sure, but the car still needs to be in the window before we start worrying about those sorts of things.
Yeah, exactly. Yeah. And you can easily get lost if you're outside the window and then you start moving things around, you can get lost pretty quick. So
years ago, we ended up over in the UK for the Goodwood Festival of Speed, and as part of that trip, we ended up visiting Joda Sport, who run the Jackie Chan LMP, LMP2 cars? I forget now. It was an Orica anyway, but the point of the conversation was that before they go to any race, they've basically run all of the different configurations of aero and chassis setup through some simulation software and basically go to the track with a big old folder of settings. So basically if the car's suffering from high-speed understeer, it's not a guessing game. They kind of go through almost a flow chart of what change to make and what magnitude. Are you doing sort of similar IndyCar so that you don't, if you were just saying before, if you're kind of out of the window, you've got a quick way to get yourself back in?
Yeah, I mean, I think all the teams will probably operate slightly differently in their own way. But yeah, that's basically your challenge as the engineer is, you're going to have the vehicle set up down to some pretty minute details, where you start moving things a millimeter here or there and it makes a massive difference. And you might have varying components that you can add and take off the car. So, you've got a challenge of communicating that with the mechanics who are installing those parts on the car, to make sure that you're understanding each other correctly in terms of how they've put it on the car and set it up as how you think it's reacting. You've got to do your own work in terms of analyzing how those things work and how you put those into your computer models, whether it be simulation or how you do your calculations on where suspension components are at or aerodynamic components are at. So, you need to do your own work in terms of understanding the calibration of all that and where those things are at and making sure that they're being installed on the car how you think so. That's the big challenge of the engineering group in setting up systems to make sure you understand it as best as you possibly can. And then when it actually goes out into the real world, is it actually performing in the real world how you think? And it gets really, really complex. So that's the challenge as an engineer, is looking at the resources you have, whether it be budget or staff or whatever, and how you apply that to achieve that as best as you can.
Yeah, that makes sense. Just in terms of the simulation, sort of how well does that sort of validate in the real world? If you make a change to a component, let's say a spring rate or anti-roll bar or whatever that may be, even aero in simulation, how does that correlate to the real world results? Is it normally pretty on point, or is there always a bit of room for error?
Oh, I think, well, it's a standard saying, input equals output, so. No, it can correlate really well, but in some things will correlate well and some won't. And it comes back to, the effort you put into trying to get that correlation correct. But then also accepting that it's a tool like anything else. So using it in conjunction with other ways you might be analyzing data that's coming off the car, or just what's happening out in the real world and how you analyze that. So yeah, it's a tool at the end of the day.
How much weight do you sort of put on, and I'm actually making some bold assumptions about the direction your time in IndyCar went, but we'll talk more about that. How much weight do you sort of put on data versus direct driver feedback in terms of a direction for improving the car?
Yeah, I think it's really important, as you get sort of up higher series with the more professional drivers, I think that's where their skills come into play. But yeah, it's a tough, I think to be honest, I probably would rather not answer that one, because it's a tough one. You're kind of saying, that's part of the skill of a driver for sure. The driving, they can do just the driving, and some of them are better at the stuff outside of the car than others. But does that necessarily make one better than the other? Some of them are, some of them aren't. But yeah, some of them are better outside.
I guess as soon as you're already in IndyCar, even be it a smaller team, you're not dealing with weekend warrior sort of grassroots drivers, so you probably already got a higher quality driver in there that's able to analyze what the car's doing in a lot more detail. I think if you sort of go to the average sort of club level race event in New Zealand on a weekend, you could probably turn the damping settings from full hard to full soft, and a lot of the drivers probably wouldn't even recognize the difference. So at that point, I think you have to maybe disregard the driver input as much as you're actually relying on the cold hard facts of the data. Does that make sense to you?
Yeah, no, absolutely. But I think you even see it, I think, just watching racing on TV, how the drivers interact with different engineers, and those are important relationships, and how you work together to bring two different ways of thinking and understanding of what's happening to communicate and sort of maximize what you can achieve out of it. It's really important.
Yeah. All right, so now to take a step back, I just mentioned sort of taking a bold assumption into your development in IndyCar, but sort of over the time you were working there, can you tell us how long you were in IndyCar and how your role did progress?
Yeah, so I did around six years over there, and sort of, as I say, started off in data engineering roles, involved in sort of sensors and electronics and instrumentation, and have been involved with that my whole career. That sort of never went away. And then over time got more involved with, fuel strategy, race strategy, and then also all the testing that you can be doing, whether it be simulation and modeling, wind tunnel testing, and some of those components as well. So sort of morphed into more performance engineering and supporting that stuff with instrumentation and data.
Right. And as part of that role, were you looking more at the performance data track side as opposed to just keeping the systems operating?
Yeah, trackside, but also away from the track as well. Like it sort of never stops. So, obviously whenever you do test sessions or wind tunnel or anything like that, there's a lot of analysis and preparation that has to go on away from the track. So yeah, a bit of involvement in all of it, which I think that's the quite exciting thing about IndyCar, is it's big enough where there's some really cool technology and some really smart people and very experienced people who are working in it. But because it's still relatively small, it's a great place to be able to get involved in all sorts of different areas of the performance of the car, which for me was awesome.
Would that be dramatically different to, let's say, Formula One, where the teams are bigger and your role is a lot more sort of single focus?
Yeah, look, I'd assume so. Obviously, I never worked in Formula One, but yeah, the teams are magnitudes larger than the IndyCar program. So I would assume, yeah, you probably focus a little bit more on whatever your expertise are. That would be my assumption. But yeah, definitely for IndyCar, I enjoyed the fact that you could get involved in lots of different areas.
Yeah. In terms of testing, obviously, sort of Formula One's a lot of noise about cost caps and sort of limited testing and aerodynamic wind tunnel tests and how many cycles they're allowed to do. Is the same sort of restrictions in IndyCar, or is it a little bit freer?
No, IndyCar definitely probably have more restrictions than I think. Definitely during my time, there was limits on test days you could do and wind tunnel testing and whatnot. And yeah, look, at some point you have to have restrictions in place because the costs will just never end. So,
Well, I guess that just means that the bigger teams with bigger pockets just can run away from the smaller teams by doing more testing.
yes, yeah, but even at some point, I guess it might become a challenge for the smaller teams to even operate. If they can't compete or even get the cars on the track. So there has to be a balance there somewhere, I guess. So
Yep, no, that makes sense. All right, so let's sort of move forward. What sort of was the next adventure, and why did the door shut on IndyCar for you?
yeah, no, I was quite fortunate to sort of be working in a contract capacity with Penske Racing sort of towards the end there. So when they set up the program to come to Australia to set up DJR Team Penske in the V8 Supercars, I took that opportunity to move back to Australia, and that was going to be a bit closer to my family here in New Zealand as well, and that was a pretty unique opportunity to get involved with. So yeah, so I moved to Australia and then was there for about 8 years working through the DJR Team Penske program. Yeah, that was an incredible experience. I think it's one of those opportunities where there's a engineer or a mechanic or someone involved in the sport. I think that was a period where that's what you're striving to get to work in. I think it was a very unique opportunity that I got to be a part of that program, and that was incredible. So.
In the southern hemisphere, V8 Supercars is the top echelon of motorsport, really, and I think they've done an amazing job at putting on a really good show. It's always incredibly close racing. For those maybe from other parts of the world who have never heard of V8 Supercars, could you give us sort of a 30-second, 30,000-foot overview of what the category is? And I guess, in your opinion, what makes it so competitive and so good?
Yeah, so I guess it's formed well before my time, but effectively it's a race series of road-going cars, sort of similar to NASCAR, but it formulated, I think, back in the beginning as road cars that were racing. Traditionally, it's been sort of paired between Ford and Holden, with the largest manufacturer, Holden or a GM brand at the time, sort of been a rivalry between those two brands traditionally, with some other manufacturers in there as well. But it's just got a history that goes back a long way. And then the cars have obviously, as race cars have sort of evolved over time to sort of the last couple of decades, where they've been a purpose-built race chassis that has the bodywork of the road-going car fitted to it.
So we're now talking essentially a control chassis that's tube frame. So it's not really a road-going car anymore. They just look like it from the outside.
Exactly. Yep. So it's a tube frame chassis with a road-going bodywork attached to it, and so yeah, they look like a road car, and with a lot of horsepower, obviously from a V8 engine, rear-wheel drive.
We're talking sort of around 600, 650. Does that sound about right?
Yeah, be somewhere up around there. So yeah, quite a fast car and quite heavy, and they move around a lot on the track. So I think to watch them is quite impressive, and takes a lot of skill by the drivers, I think, to really make them go fast. So yeah, it's an interesting category to watch.
I think, yeah, what makes them exciting is watching how much those cars do move around. I think for the amount of power they've got, as you mentioned, they are quite heavy. They do move around on the tyres because the tyres aren't huge, and that's all sort of part of that spectacle. But you watch a driver sort of wrestling one of these things around a racetrack, and while I'm not trying to downplay Formula One, you can see they're really manhandling the cars. They're very, very physical. Often they're making sort of brake bias changes 2 or 3 times a lap, along with anti-roll bar adjustments. So there's always something going on. They also have a category, they've stayed away from paddle shifted gearboxes. So I think that, and no ABS, there's a lot more driver involvement to really get the most out of the car, and that sort of, I think, really means that the fans will get behind a certain team or a certain driver, and that makes it much more exciting when they're watching. Do you sort of agree with that sort of statement?
Yeah, no, I think that makes sense. Yeah, I think coming from IndyCar to the supercars, obviously the technical aspect of the cars was obviously a lot lower. Like, there's definitely not as lot of tech equipment on there, but I think it's really in an aim to focus on the spectator, and particularly, there's a large following in Australia of the series. So a lot of it is spectator based, and making the car something that's really fun to watch, and also limiting the costs of the series to make it competitive for a variety of entrants to be involved in it. I think they've done a really good job of balancing that. But, it's a really competitive series. There's a lot of teams and intelligent people that have been involved in it for a long time. So there's a lot of practical knowledge there on, how to operate these cars and in this series. And so it's cutthroat competitive, to be there trying to win races and be at the top. It's definitely not easy, that's for sure.
Yeah, 100%. This is another sort of take on, IndyCar, you've got the control chassis here, and Supercars, it's kind of a control chassis, but then you've got completely different bodywork on the chassis, and you've got different engines. They're still trying to get parity, though, between the different cars. So really, on the day, it's going to come down to who got the setup right, who's in the window, the better driver, the better strategy. So what are the challenges in getting parity across completely different chassis like that?
Yeah, look, it's really, really hard. And I think when you're trying to limit the cost as much as possible, it's a big challenge. You can only do so much testing, whether it be on the track or in the computer world or in wind tunnels, whatever. It's a hard thing. And we don't necessarily have those resources down here in the Southern Hemisphere like you do in the Northern Hemisphere. So even to go and do wind tunnel testing is a challenge. You really have to go overseas to do it properly. And that's a costly event to do. So as I'd say, like, there's a practicality, I think, to that series. And so the challenge is just trying to find the practical solutions to work within the community that's there to try and achieve what they need to achieve. So yeah, it's a real challenge, but it's just something they just keep working on. So yeah.
Yeah. I guess the problem with parity is it's sort of a losing battle because you can't keep everyone happy.
Yeah.
I went through this in our local NZ-V8 touring car series, and I was the parity manager with engines, and basically we used drive-by-wire throttle mapping to match the power curve of the lowest powered engine with, I think it was 3 different engines at the time I was involved, and I think I did a pretty good job of it. You could literally overlay a TRD 5-litre engine over the top of a 6.2-litre LS3 engine with a big cam in it and a Coyote Boss engine, and they were all within 1 to 2 horsepower. But that didn't stop arguments on track. So yeah, it's very difficult when parity comes into things. Balance of performance in the touring car world as well is another area where I think it's always difficult to find that balance. Coming back to your specific roles within DJR Team Penske, what were you sort of in charge of? And again, I guess just like the IndyCar question, how did your role sort of develop over the seasons you were with them?
Yeah, so I sort of took on a few variety of hats during my time there. Again, a lot of it was involved around the data engineering and instrumentation and sort of setting those programs up. And with that comes sort of fuel strategy and performance engineering analysis type roles. And then I was also involved in race strategy for a long period of it as well. So yeah, sort of wore several different hats throughout the time. But again, similar to IndyCar, where it's a great platform where you can sort of get involved in a range of different parts of the process depending on your skill set. But you also have to as well. I think there's probably the teams are probably smaller again from what the IndyCar teams are as well. So everyone within the team has to sort of do multiple roles and be willing to do different tasks, just because it's a smaller program than some sort of IndyCar and Formula One. So
of course. I guess that does make it exciting, though, because you're not just doing the same thing day in and day out. There's always going to be a bit of variation and a bit of flexibility in the role.
Yeah, absolutely. Yep.
I'm interested if we can sort of dive into what's involved with race strategy. So you can talk about this in as much or as little detail as you like, and this could come from an overview of both your involvement in IndyCar as well as Supercars. I think from the motorsport that I watch, often the strategy is the thing that makes the difference between winning and being midfield. And some of these calls need to be made split second. Someone hits a wall, safety car gets called, what are you going to do? Can you sort of give us your take on what considerations go into this, and how you're actually processing everything that's going on in real time to make strategy calls?
Yeah, I'll touch on it briefly without, I guess, going too much into team-specific stuff. But, I think, at least from my experience in IndyCar and Supercars, it's kind of similar in sort of how it operates. But generally, you'll have some form of timing software that is probably more detailed than what you'd be seeing, a lot more detailed than what you'd be seeing on TV. And that really forms, I think, the basis of your decision making. And there's a variety of vendors around the world that create software that you can purchase for that, as well as some teams would perhaps create their own tools to do that. And then on top of that, you can sort of be creating your own more purpose-built strategy software tools as well to do analysis and whatnot. But I think for me, obviously the strategy stuff started off for me in IndyCar. And as I say, just working in the ovals, there's a lot of just really fascinating things. I think you probably, if you watch an oval race, sometimes there's just simple things like on the smaller tracks, if you pit under green, you'll go 2 laps down, so you end up having to look at some real simple rules to begin with for different tracks and where you go, sort of that are no-go sort of things, for instance, there. Ideally, you don't want to put under green because if you go 2 laps down, it's hard to get that back. So you're going to start with some basic rules that you're going to need to apply to the track, whether it be an oval or a road course or a street course, and that applies whether it's in Supercars or IndyCar. And then after that, you're then going to have to look at your fuel strategy. So how far can you go on a fuel tank? When are you going to have to make pit stops? And so there you have an idea of when you're going to actually physically have to fit fuel in to be able to finish the race. Then you're going to have to look at your tires. What does tire life look like? Obviously in IndyCar, they have 2 different types of tires. They have a faster tire and a slower tire. So they're going to wear out at different rates. And you may not know how long some of those are going to last. So I think I watched the IndyCar race last week at St. Pete, and they had a very aggressive, fast tire there that I think would last about a lap or 2 in qualifying.
Right.
But then over a long stint, you may only get 10 laps out of it or something. And they don't know that going into it really, because you only get to put the tyre on for qualifying or maybe in practice. So you don't actually use the tyre very much leading up to the race. So, how are you going to make these decisions on how long you think the tyre is going to last? And that's going to require a bit of experience combined with some form of analysis that you're going to do yourself.
I'm guessing you're also relying there on driver feedback about how the tyres are degrading lap after lap.
Yep, exactly. Maybe you're going to compare it to other tyres you've raced with previously. And this was similar in Supercars as well. At various stages, they would have a hard and a soft tyre that you could use. And again, you might end up in a similar situation where you're going into the race having not run one or both of those tyres very much. So you have very limited information to know exactly when the opportune time to pit and take that tyre off is. And so, you've got to use a range of experience and tools and to sort of decide that. And a lot of time you're going to have to decide on the fly. So that's exactly what you're talking about, quick decision making.
Being able to pivot your strategy when new information comes to hand.
Exactly. And adapting to it as you go along. So it's, massive challenge.
Yeah, and I guess the problem with the position is you either look like a genius or you're not very popular if you get a strategy call wrong.
No, absolutely. Yeah, it's it's a tough one. But I mean, I think your comment regards, it's the difference between you, winning and losing. I probably disagree to it to some regard. I think in reality, to be winning, whether it's in IndyCar or Supercars, you really have to be firing on all 5 cylinders, excuse the pun. You're gonna be nailing everything.
All the ducks have to be in a row.
Exactly. You make, in both of those series, you make one little mistake wherever it is, and there's 5 other cars that are right there ready to pounce. So yes, you need to nail that, but there's 100 other things that you need to nail as well. And that's where you've got to have the team in the background who are all just working on their tasks and passionate about trying to maximize and achieve the best they can and what they're working on, because you've all got to come together at the same time to try and nail it. So
I guess the reality here as well is there is an element of luck that comes into this. Just one example there would be the timing of a safety car, whether you can pit or whether it happens too late and you don't get the opportunity to dive into pit lane. Maybe the other competitor does and they get to pit under safety car while you have to pit under green. So, those sort of things, luck is just the luck of the draw. You can't really control that.
Yeah, and I think that plays its part in different ways. Like in IndyCar, that's definitely quite a big part. Obviously, in IndyCar, when a safety car comes out, they will close pit lane, so you're not allowed to pit until the cars pack up and then you go in. So that has a massive impact on cars that are perhaps pitted before that happened or didn't. And there's definitely instances that will happen each season where someone is dominating a race and a safety car comes out and unfortunately they haven't made the pit stop. So no matter the fact that they were dominating the race and would have probably won it under green, they're now via this pit sequence shuffled back into the pack and don't actually win the race. And maybe the impact of that is less in supercars because the pit lane stays open. But supercars has other things where, at least traditionally a few years ago, the fueling time, to fill the car was about 30 seconds. So, and you would share one pit bay for a 2-car team.
So double stacking became a consideration.
Exactly. So, a lot of the time in supercars, you now have to look at how you want to mitigate that and what are you going to do to try and avoid that happening, or maybe you decide that it's not a bad thing to happen. It just depends how you want to play it. But yeah, that's a luck thing where if a safety car comes out at the wrong time, yeah, you can end up with a situation where one of your cars is going to have to sit in pit lane waiting for the car ahead of it to finish or complete its pit stop. So I feel like luck maybe plays a little bit more of a role in IndyCar. Like you really have to have everything, all your ducks in a row, and the luck duck has to be with you as well. Whereas I think in supercars, it's probably less of the case, but you do perhaps have to put a lot of risk management in place to sort of try and at least mitigate the impacts of if some of those things do happen. And you have the option to do that, and it's up to you whether you want to play the risky game and hope for the best, or whether you want to put some, maybe not do the optimum strategy, but just try and cover yourself in case some of those risks happen. So I think there's a bit more room in supercars to make those decisions yourself. But again, you can make those decisions and then it doesn't work for you or something. So it's hard.
I've always wondered as well, if you've got a car that's in a potential title fight, how you sort of plan out your strategy for what may be optimal versus whether or not you react to what your main competitor in the title fight does on track. Can you talk to us a little bit about those considerations?
Yeah, look, I think it's probably different for different teams, and I think it probably comes down to what your goal is at the end of the day. Are you trying to win a championship? Are you just trying to win races? Maybe you're a smaller team and here's your one chance to win a race, which mostly doesn't happen, so you're obviously going to go all in and just try and make that happen. So I think it really depends for the team and what they're trying to achieve as their goal. And I think it differs from the top teams, obviously, down to the lower teams. Obviously, say, for example, in IndyCar, there's different money rewards that come for if you're in what they call the leaders circle, and so you could be one of the bottom teams that are really just trying to be in a position to be within that money pool for the following season. So yeah, to them, their championship is trying to make sure that they're in the winner's circle for the next season or what have you. So yeah, it can just really differ between the teams and what they're trying to achieve individually.
Yeah, fair enough. All right, so let's again sort of end out this chapter in supercars. What sort of closed the door on that chapter and what was next for you?
Yeah, so I guess by that point I'd had a pretty good stint in my motorsport career and had a lot of success and it was a pretty incredible experience. And I was sort of looking for what the next chapter would be for me. And I think at the time I was sort of becoming more and more mindful of climate change and really wanted to start doing more myself, but just didn't know anything about it. So I went back and did my master's degree in sustainability, and over a few years did a lot of research in a range of different sustainability contexts, but did a lot of research on transport decarbonisation, and I think that sort of fitted with my skill set.
This is quite an interesting change in direction. I mean, obviously, in the last couple of decades, there's been a lot more understanding around climate change and the effect of burning fossil fuels. I would say that most people involved in motorsport probably understand that, but maybe aren't actively trying to reduce their carbon footprint. So, yeah, interesting change of trajectory for you.
Yeah, no, definitely. I think really for me, I'm an engineer at heart. I'm a problem solver. So I spent my initial part of my career, and the problem was going fast around a racetrack or trying to win championships. And so for me, I think I trust enough of the data scientists who are out there who have spent their lives looking at climate change for multiple decades now. So for me, I think it's just a case of shifting my problem-solving skills to another problem. And for me, I've sort of narrowed in on transport decarbonisation and really just looking that from a problem-solving point of view. Okay, well, what is the problem and what would we need to be doing if that's what we're trying to achieve? So, yeah, I think from the outside, it seems like a massive swing, but I think for me, it's just another problem, and I'm just changing my skill set to try and solve another problem, I guess.
Okay. Yeah, that makes sense. I do like the perspective of, obviously there's a huge amount of debate, particularly in the motorsport world, about climate change and fossil fuels and all sorts of things that I'm certainly not interested in getting into. But when you take the scientific approach of here is the data, what is the data saying, it kind of takes the personal viewpoints and subjectivity out of it to a degree. So you're just left with the data. What's the data telling us? What do we actually need to do? Let's just maybe define this term transport decarbonisation. I mean, there's probably a pretty good hint in the name, but could you do a better job of explaining what actually you mean by that?
Yeah, so I think really it comes back to, the definition of net zero, and really sort of globally, that is the direction that for the most part society is choosing, is the goal, is either net zero by 2050 or in some cases some years later. But by the UN definition of net zero, it means reducing emissions to zero as much as possible.
As much as possible seems a little bit fluffy.
Well, on top of that, it basically then any emissions that you can't get rid of or can't eliminate, then you need to capture those from the atmosphere. Because the reality is everything we do really creates emissions one way or the other. So it's pretty much impossible to get to absolute zero.
Okay, that was going to be my next question. Just from my perspective, it seems like possibly an unrealistic aim. Sounds like obviously you agree.
So that's why I think the definition of net zero is important, because it's basically accepting that you're not going to be able to get to zero.
But we can do a whole lot better than what we're doing now.
Yeah, but it also, because the fact that anything you do put in the atmosphere, you need to pull out somehow, which at the moment really is planting trees. And there's a range of technologies that are we're hoping will come online at a mass scale that will be able to complement that. But it kind of highlights really the challenge we have if that's the goal you're trying to get to. Because you really need to, anything that you can get to zero, well, you need to, because there's a lot of industries where you're not going to be able to, if you still want to be able to have aluminium, if you still want to be able to make steel, there's a lot of tasks where getting to zero is pretty much impossible. So it basically means everything else that you can get to zero, you need to, and you need to find a solution on how you're going to do that. So it's important, I think, to understand that definition, because it kind of highlights the challenge that you're facing if that's what you're trying to achieve. So
sure. Yeah, I think it's important to have a more well-rounded understanding of what we're actually trying to achieve and the impact of these different industries, which you've just mentioned on that aim as well. Obviously, electric vehicles have been a big push over the last decade or more in terms of reducing the reliance on fossil fuels. I think more recently there's maybe been a little bit of a pushback on EVs for a variety of reasons. Maybe the infrastructure, depending where you are in the world, isn't quite there to make them practical. And also there's talk as well about the ridiculously high levels of depreciation that some of these EVs are seeing. What's your sort of take on where the future's likely to go with EV versus maybe hybrid versus internal combustion?
Yeah, sure. So I guess I'll probably bring it back to the research that I've done over my time, which in the end, I published a book last year called Technical Challenges of the Battery Electric Vehicle Transition. And so this was really a summary of the research that I looked into from other authors who have published papers on these topics to try and, I guess, answer those questions of, how does the EV world stack up in terms of what we're trying to achieve in net zero? And so, for me, I found a lot of challenges of relying or expecting that EVs are going to be the only solution and just solve net zero for 2050. I think there's a lot of energy implications there. I've presented a lot of research on the life cycle emissions on the electric vehicles and the reality that they actually play.
Can we just stop and dig into that one point, since you've just raised it? I think that's something that's really easy to overlook is, it's not just about once you've bought an electric vehicle, obviously, depending how you power it as well, but assuming you're living in a country maybe like New Zealand where the majority of our energy is sustainably produced, not where we're burning fossil fuels necessary to create electricity, the actual running of the vehicle should be net zero or relatively close to. But when we actually look at the sort of cradle to grave of the production of an electric vehicle, what does that actually look like compared to internal combustion?
Yeah, no, it's really important. And so from the research papers that I've sort of looked at and presented in my book have sort of highlighted that in a crude sense, a lot of it comes down to the charge electricity of the vehicle and also the construction emissions. So the construction emissions of the electric vehicles are more than a conventional vehicle or a combustion engine vehicle. And really the performance of the emission saving of an electric vehicle come down to largely the charge electricity that you use to charge it. So from some of the research I've looked at, for example, charging an electric vehicle in a country like Australia, which has a low renewable energy grid and a large coal dependence, over the life cycle of a vehicle, charging an electric vehicle is unlikely to be better over the life cycle on emissions than a conventional vehicle at this point. And even using high renewable grids, for example, in New Zealand, which is almost 90% renewable electricity, you're probably over the life cycle going to achieve half, maybe a little bit lower on the life cycle emissions of a conventional vehicle. So I think electric vehicles will play their role, but trying to rely on those to achieve what you define as net zero is not necessarily going to be the case as they currently stand.
Sure. Yeah. I mean, without trying to go too deep into things I have absolutely no domain expertise on, it sounds like from what you've just been explaining, a big part of the solution is going to be finding more renewable ways of creating electricity in countries around the world as opposed to relying on burning coal to make it.
Yeah. So to get your true performance out of an electric vehicle, you need to be charging it from renewables, whether it's ideally solar or wind power, but other sources as well. But likely what I'm trying to present in the book is you're going to have to look at other solutions that are beyond just electric vehicles. And that's going to be a challenge. And some of these things are going to take decades to implement and change. So I think I'm just trying to highlight and sort of just try and start the conversation on what we really need to be looking at if we want to be achieving that, and what those things can be. So
again, without sort of going too deep down the rabbit hole, could you give us sort of some key points of what those things would be?
Yeah, so I mean, I think growing up in New Zealand and living a lot in Australia, I think US is similar as well. There's a lot of sort of authors out there who have presented the challenge that, you know, these cities that we live in have been designed since the motor car has been around. So, you know, we've designed our lives on the reliability, on having to have a car to work. Whereas, you know, if you go to places like Europe, the city layouts are completely different and allow you to function without it. So I think down the line, there's going to have to be a balance of finding how we use probably electric vehicles in a more automated sense, which is like a last mile type scenario where you're using other design layouts of your cities to reduce how much transport you need to actually have. And rather than sitting in traffic for hours on end, if you're sitting in your car on the motorway, not moving for an hour and a half plus a day, you probably need to start asking, is there other ways you can be designing life to be around you so that you don't require to move as much to have the things accessible to you in your life, and then complementing that with other transport modes, which, you know, on a life cycle assessment, using public and active transport or smaller vehicles are going to be less than an electric vehicle. So really using the electric vehicle to try and just complement using these other modes of transport, as well as trying to design your life so that you spend more time accessible to the things you want to do in your life, rather than sitting on a motorway in traffic for 2 hours every day going to work.
Yeah, that went deep really quickly, but all important considerations. I think, unfortunately, the redesigning of a city layout is a very, very big stumbling block to re-engineer if you're not starting from scratch with a city. One thing I do notice with New Zealand, and I'd say probably Australia, is very similar. I don't know if we do a great job of public transport options. I've just come back from a trip to Japan, and their rail system is just absolutely next level. It's clean, it's fast, it's cheap, it's efficient, and if you miss a train, there's typically another one in like 3 minutes time. And I think for me, as a car lover, that's sort of efficiency is what it would take for me to get out of my own car on a day-to-day basis for transport around a city. And unfortunately in New Zealand, we just don't have that yet. And again, massive infrastructure to re-engineer.
Yeah, that's I think what I'm trying to highlight is this is going to be a huge challenge, and we, you know, I'm sort of trying to bring it up for what are we going to have to be doing in 30 years time, and some of these things even achievable, possibly not. But I think the point I'm trying to make is if you are just trying to convert your car fleet to electric vehicles by 2050 and hope that that's going to achieve your net zero goal,
going to fall woefully short.
Yeah. And then some other things I present from some other researchers, as well as my own modelling, is even the challenge of converting a complete vehicle fleet to electric vehicles. In Australia, there's over 20 million vehicles, and they sell 1 million a year. In New Zealand, it's almost 5 million vehicles, and you sell 100,000 new vehicles a year. So even if today you were to say, hey, we're going to swap all our vehicles to electric, the practical challenge of even trying to achieve that by 2050 is really difficult.
Another, just while you're talking there, something popped into mind. Another sort of consideration that I think most people are just completely blissfully unaware of is the requirements on the energy infrastructure. So a friend of mine who's an electrician mentioned, you know, a urban subdivision like we have here in Queenstown with, I don't know, several, maybe 1,000 houses in it. And if that entire subdivision all transferred to EV and everyone wants to, of course, plug their car in and charge it overnight, the current grid would actually need a significant upgrade to be able to cope with the instantaneous demands for that. So, I mean, I guess, assuming that is an accurate statement that he's made to me, and I'm just rehashing it here, I guess there's a lot of unforeseen situations that are going to crop up here that need to be dealt with.
Yeah, look, at the end of the day, transport or to move objects around is an energy problem. And when you bring it back to the fundamental equations, it's related to the mass and the weight of the object and the velocity of it. And unfortunately, when you look at the kinetic energy equation, velocity has a squared term in it. So if you double your mass or your distance, crudely, you're doubling the energy required. But if you double the velocity, you're quadrupling it. So the faster you want to go, the less energy efficient it is to do it in a fundamental sense. And then you have the efficiency of the whole process of what you're doing, whether it's an electric vehicle or an airplane or whatever on top of that as well. So yes, absolutely, it really requires us coming back to looking at how much energy are we using to move ourselves around. So there's not going to be one solution that fixes it. We're going to have to require multiple solutions, and electric vehicles will play its part to a degree, but there's going to have to be energy reduction solutions that play out, as well as behavioral change to choose other transport modes that are more energy efficient to move us around. So yeah, the demand reduction is a thing. I think there are plenty of sort of researchers out there who have published papers on how we can be using demand, I guess, automated demand for the charging of electric vehicles to try and at least balance out that as much as possible. But yeah, at the end of the day, the faster we want to go and the more objects we want to move around, it takes energy to do that. And the energy has to come from somewhere. And fossil fuels are massively energy dense compared to renewable energy sources. So other than uranium, most renewable energy sources are magnitudes less energy dense than fossil fuels. So if you're going to step away from fossil fuels, there's a reality there where you're now trying to use a much less energy dense fuel source. Now, yes, electric motors are more energy efficient than combustion engines, but there's still this significant reduction in energy availability from the renewables. So there's a practical limitation that comes from that as well.
So that kind of pretty much comes into either you're going to have a car that weighs significantly more to fit more batteries into it, and there's a practical element of how many batteries you can fit in a car and still have room for passengers and luggage, or alternatively, you've got a limit in your range.
Yeah, no, for sure. But I think the point I'm trying to make is in 30 years' time, you're going to have to be thinking far beyond that. In reality, you're going to have to be either putting more passengers in the transport modes that are moving you around, or if you're individually moving around, using as smaller and lighter mobile devices as you can. So yeah, it's not to say that I think they're going to go away, but you're going to have to start using a range of different solutions to try and achieve it beyond just hoping that 20 million electric vehicles will
fixes it. At the risk of going even deeper down this rabbit hole on what is an unfortunately somewhat depressing conversation, but is the reality that we are facing. And I'm not sure if you've got the data on this. I'm guessing you probably do. In terms of cars, our sort of personal vehicles, how much of the problem is that globally versus other forms of transport? So I'm talking here air transport, which doesn't lend itself well to electrification, container ships, that sort of thing. Are we a big part of the problem, or 50-50? Do you sort of know where we stand?
Well, I guess if you look at the International Panel for Climate Change reports, they sort of suggest that almost a quarter of global emissions come from transport and 70% of it comes from road vehicles. So
okay, so we are the problem.
Yeah, so that's the unfortunate thing is, we've been talking a lot about motorsport here and things, and to be honest, if you start to look at that as a problem, it's insignificant compared to where the bulk of our emissions come from. So yeah, I think in terms of a risk is motorsport still going to be around for a while? I don't think so, because the real problem is just you commuting to and from work every day at the moment. That's the low hanging fruit, is if you're using fossil fuels to drive yourself 300 Ks to and from work every week, and there's 20 million people or however many millions of people doing it, unfortunately, that's the reality. That's your low-hanging fruit. So until we say, okay, well, how can we maybe reduce that, then some of these other things are pretty insignificant. And, the likes of, I think, motorsport now, a lot of them are using sustainable base fuels or ethanol and whatnot, which I think is pretty great. But the limitation will be, obviously, there's 1.5 billion cars in the world. So there's not realistically going to be enough of that to be produced to just power 1.5 billion cars by synthetic fuel. So, those fuels I think will play a part in some small scale stuff, but then you've also got to consider you've got aviation and shipping, which really do not have a solution at the moment. So again, it comes back to anything that we do have a solution that we can be applying, we need to be applying it, because there's plenty of industries or parts of our society that don't have a technology or a solution that is available yet, and not sure whether there will be. So you need to start figuring out how you can prioritize some of these solutions to those, because otherwise, they have nothing that they can do other than stop doing it. So
easy to say, hard to do.
Yeah. So at some point, I think you have to start looking at what these solutions are, because if you don't, then the reality is someone else will probably make that decision for you, and you'll just have to deal with whatever that is. So.
Well, I'd have to admit, Brad, that's been a somewhat sobering discussion. It really puts it all in perspective, and I don't want to bring our listeners down. Unfortunately, this is the reality we're facing, and sort of as you've mentioned there, a lot of these solutions aren't going to be something that's going to be a 2 or 3 year fix. It's more on the sort of 10+ year time horizon. So we really need to crack on.
Yeah, and look, I really try my best to avoid talking about the stuff in a doomsday sort of type scenario. But the reality is there are a lot of solutions out there that we can be adopting, and I go through a lot of those in my book. And I think in any case, when you first start looking at change, it's quite resistant. But the one thing that has actually amazed me when I started looking into this is when you actually sort of just stop and maybe open up a bit more and be a bit more accepting of what some of these solutions can be. There's actually a range of benefits that you can actually start to achieve from some of these. And I think for me, a lot of it is probably quality of life stuff. So, as I say, I've been back in Auckland for a month or so now, driving around in the traffic here, and it's just crazy to think, why am I sitting in a traffic jam for an hour and a half just trying to go from one side of the city to the other? There has to be a better way, and I think, working from home is an example that sort of came out of COVID, where, there's still debates going on over this, but, that's a classic example of, if you stop for a second and say, hey, is there another way you could be doing something? In that scenario, it was forced upon us by, the pandemic, but
allows you to suddenly look at what has been a norm that's just accepted, and maybe it doesn't need to be.
Exactly. And look, that's not going to work for everyone, and none of these solutions are going to work for everyone. You're going to have to, choose how you apply them to help. But, I think that's a good scenario where that solved or would have reduced a lot of transport for a lot of people. And it wasn't really a technology. It was just a life change. But for a lot of people, I think that would have been a massive improvement or benefit in quality of life, and they can now spend more time with their kids or going to the gym or whatever it is they do in their life. And for other people, that may not work. So, I think for me, it's just been kind of eye-opening if I actually stop myself being resistant to it and just sort of saying, oh, hey, let's just have a listen and look at what some of these solutions are, and does that give me more time to go do the things I'd rather be doing than sitting in a traffic jam,
Yeah, totally fair. Sitting in traffic is one thing that absolutely drives me crazy. In my old business, I spent quite a bit of time in Auckland, and for those who don't know New Zealand, Auckland's our biggest city by quite a margin. I think it's probably 2/3 of New Zealand's population up there, so a few million people. And yeah, an hour and a half morning and night would not be an unacceptable or an abnormal amount of time to be sitting in traffic. There's no way I could deal with that. I'd definitely find a different line of work or something that got me out of that. But for a lot of people, that is the reality that they have to deal with.
Yep. And for me, I think I'm just like, well, hey, maybe I can help find a way where, you don't spend that 4 hours a week in traffic, and you can now go do something you want to do, and maybe at the same time we'll reduce some emissions to try and help achieve the net zero goal. So that's sort of, I guess, a more positive way of how I'm trying to look at it, if I can.
Yeah, I feel like if we look at some sci-fi movies, I just don't understand why there's not more effort being put into developing teleportation. That would solve all of the world's problems instantly.
Yeah. Yeah.
Unfortunately, a little bit unrealistic, but it would be nice. I just wanted to take a moment out of our chat with Brad here and talk about a course that's obviously really relevant to what we've been chatting about within this interview, and that, of course, is our EV Fundamentals course. Normally valued at $199 US, you can use the coupon code FUTURE50 to get $50 off, bringing it down to just $149 US. Now, obviously, anyone can go and purchase an electric vehicle off the showroom floor or second hand, but in the enthusiast market, there's lots of people who are wanting to learn more about how electric vehicles work, maybe getting their hands dirty, making their own EV swaps, and this course is a great introduction to all of the systems that you'll need to understand. We start with EV basics, talking about electrical basics as well as upgrade limitations, EV conversion basics, and some of the things that will absolutely destroy your range in an electric vehicle. We then move into the EV motor itself. We talk about the different types of motor and the concepts involved, as well as limitations in cooling. Hand in hand with the motor is the EV inverter. We talk about what the purpose of the inverter is, the control systems, and we talk about inverter limitations and cooling. The third part really of the electric vehicle is the batteries, and we talk about battery cells, the battery module, the battery management systems, what damages a battery, and of course the cause of battery fire, something we obviously want to stay away from. There are some other auxiliary devices you'll need to understand as well, such as the vehicle control unit, the DC-DC converter, and the onboard charger. We also discuss some of the information you'll need to understand around cabling, wiring, and design, as well as the thermal system for an electric vehicle. We finished this off with a couple of EV project case studies so you can really see how all of these elements come together. So remember, normally that course is $199 US. Use the coupon code FUTURE50, get $50 off, just $149 US. You can still break that down at the checkout into 8 individual weekly payments to make it as affordable as we can. And of course, you are still protected with our 60-day no questions asked money back guarantee. You'll find that coupon code as well as a link to the course in the show notes. Now let's get back to our chat with Brad. I guess my next question is, where do you go to from here in your career, Brad? You've got quite an interesting and eclectic mix of things that you've done. So where to from here?
Yeah, so as I say, my book sort of just came out late last year. And so at the moment, I'm sort of doing some work around that, some conferences and whatnot. So that's taking up my time at the moment. As I say, there's a lot of material in that, which is based on other people's research. So, you know, if you are interested, hopefully we'll have a link here or something. But there's a lot of references that you can see online if you go look for the book.
Yeah, we'll chuck a link to the book in the show notes so people can find out more if they are interested.
Yeah, that's great.
So post-book tour, though, and speaking engagements, are we sort of just more down this path of trying to find viable ways of getting to the sort of net zero?
Yeah. I mean, I think a lot of it is education-based. I think for me, one thing that I've found that is missing sort of from the community involved in it is I think a bit of technical knowledge that could be applied to this problem solving. You know, I think there's not a lot of sort of engineers, I guess, who are focusing on these problems. So for me, it seems that there is definitely could be benefited by having a bit more technical sort of understanding, trying to help to solve some of this stuff. So for me, that's, I think, where I'm currently just trying to help sort of apply a bit more of a technical side to it.
Well, I mean, it seems from the conversation that certainly someone needs to be doing it. So not all heroes wear capes.
Yeah.
All right, Brad, I think we'll move towards wrapping this up, and we've got the same 3 questions we ask all of our guests at the end. The first of those you've pretty much just answered, and that's what's next in the future for you. Our second question is there any advice you'd give to a younger version of yourself to help reach where you are today in your career faster? It might be a difficult one to answer given the trajectory change, but let's see what you've got.
Yeah, look, for me, I think I probably reached my goal of where I wanted to go very early on, which I never expected and certainly didn't know how to deal with that. I think probably the biggest thing I learned through particularly my time in the US and even Australia is taking opportunities when you get them. So just don't say no. I think that's the biggest thing I regret is every time I said no, I look back at it and say, there was an opportunity that I didn't go and do, So for me, I think it's just go for it and take every opportunity you possibly can.
Yeah, I think that's solid advice. There's got to be a bit of a mindset thing there as well. When you mentioned that you jumped on a plane, booked a ticket, jumped on a plane and flew to the US and really didn't have a plan at that stage, sort of built the parachute as you jumped out of the plane. That's going to be tough for a lot of young people to kind of uproot their entire life and change everything get out of your comfort zone, I guess. So maybe that is the advice there. Learn to get out of your comfort zone a bit.
Yeah, no, absolutely. Yeah, I think a lot of the times that you'll probably say no is I think when you think maybe you are going out of your comfort zone, and that can be at different levels for different people. And it's not always going to be a big thing like choosing to move and go overseas. It can even just be little things in your daily life. Should I go and interact with these other people in my classes or, so I think it can be a big scale, but it can also be a little scale. But I think every time, you turn something down, it's, you don't know what the opportunity is you missed, or you don't know who you might meet, or it could even be, choosing to talk to the person who's sitting next to you on the plane, even if it's just to say hi, and maybe it's a brief conversation, or maybe you meet someone who's really fascinating. So yeah, for me, I think it's just, take the opportunity no matter how big or small it is.
Yeah, that's actually really good advice. We obviously have a lot of guests on this podcast, and often we get the same advice rehashed, which makes sense. Obviously, there's always some key elements that are common among people who have reached some level of success, but I think that's the first time I've had that advice, which is really refreshing.
Cool, that's great.
All right, Brad, our last question for today. If people want to follow you, see what you're up to, how are they best to do so? Have you got some social media accounts you want to share? Obviously, I've said we'll put a link to your book in the show notes as well.
Yeah, look, when you actually go back to talking about choosing to take opportunities, for me, I'm actually not much of a public person. I'm quite private. So even for me, doing podcasts and whatnot is even daunting for me. It's not something I normally do. So no, definitely probably the best way is, I guess for professional stuff is through my LinkedIn, which is just Brad Eyes. If you have a question or you want to know where you can go look for some further information or maybe some of the stuff I talked about, then yeah, you can probably message me there. And that's probably the best place for, I guess, sort of professional correspondence. So.
Okay, perfect. Well, again, we'll put a link to your LinkedIn account in the show notes for those who may want to reach out at a professional level. Look, Brad, it has been a bit of a mixed discussion there, a little bit of doom and gloom, but also a lot of hope for the future. And we appreciate you sharing your knowledge, which is definitely a specialist area of the field that I haven't dived too deeply into. So hopefully we can see a brighter future for the next generation.
Thanks, Andre. I really appreciate you having me on here, and hopefully my discussions have been interesting to some of the viewers. So
I'm sure it will be. Yeah. Thanks again, Brad.
Thanks, Andre.
If you enjoyed this episode of Tuned In with Brad Eyes, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Little Ones coming from Canada, who has said, great listen. Have been listening to this podcast for ages now. Great to hear from experts on new topics and learn some new things. Well, great to hear that you're enjoying the podcast. And if you get in touch with your size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.